Welcome back to NARRATE Talks. In our previous episode, we defined the challenges of a modern supply chain and the concept of self-adaptation. Today, we are getting specific. What makes the NARRATE project truly beyond the state of art? How do we move from a simple predictive maintenance to a truly intelligent, self-healing, smart manufacturing networks? The NARRATE project isn't just about integrating existing tech. It's about pioneering new methodologies. Our specific objectives include a 30% improvement in risk identification and a 20% faster recovery time after disruptions. We are targeting a future where manufacturing is not only more resilient, but also significantly greener, with a goal of a 10% reduction in energy consumption and carbon footprint. Today, we dive into the roadmap of breakthroughs and the advanced AI reasoning that makes all of this possible. We are joined by three key architects of the NARRATE mission. Dr. Bernd Kraemer is a professor emeritus of computer science and a co-founder of ServTech, where he leads the development of AI-based data models for NARRATE Project, a pioneer in service-oriented computer with a global footprint from Berkeley to Shanghai. Bernd brings over 4 decades of expertise in distributed software engineering to the forefront of smart manufacturing. Dr. Werner is the director of research at BlueBridgeSolutions, where he collaborates with the NARRATE Project, a PhD from the Karlsruhe Institute of Technology with over 15 years of expertise. Frank has contributed significantly to the German standardization roadmap of AI and holds more than 30 patents into the field. And Jesús, back again from NUNSYS, where he leads the NARRATE Project's integration of digital twins and machine learning. With over 25 years of international experience, included a decade-long tenure leading critical system at BP Refinery, Jesús is a master at aligning complex IT infrastructure with industrial innovation. Bernd, let's start with the big picture. Where do we stand in terms of roadmap, and what are the most innovative milestones the project has hit recently?
Yeah, the project NARRATE aims to strengthen resilience and sustainability in manufacturing across Europe, focusing on processes in industrial production. It enables smart manufacturing networks to adapt on their own in response to external threats. How are we doing that? We are providing an innovation platform that you can understand as sitting in the cloud. And the heart of this innovation platform is a central digital intelligence hub. We call it the Intelligence Manufacturing Custodian, or short IMC, which is accompanied by a number of what we call digital twins for all essential elements in the supply chain. It also includes process planning and optimization tools, learning capabilities, risk assessment components, etc. And around the cloud are sitting the different suppliers with their machinery capabilities, and of course the customers who have access to these suppliers. So the Intelligent Manufacturing Custodian collects, harmonizes, and analyzes supply chain and production data to proactively manage disruptions, to coordinate actions, and to optimize supply chain performance in collaboration with users. It aims to provide end-to-end visibility and control over supply chain operations, facilitating proactive decision-making, real-time monitoring, and coordination to foster smart manufacturing networks. It helps to predict potential disruptions and thereby enhances overall supply chain resilience. The IMC custodian uses artificial intelligence, digital twins, and IoT technologies in his function. IoT technologies and digital twins, for instance, allow us to sense and predict potential risks and estimate risks and vulnerabilities and estimate risks and vulnerabilities in the network. intelligent planning, configuration, and adjustment of smart manufacturing networks and certain segments that are under question are possible dynamically. And users can respecify operations and change production, product, material types, production volume, or swap suppliers and supply chain to disruptions. To make this more understandable to potential stakeholders and end users, we offer 3 pilots. The pilots aim to address the challenges of the project and to support users to provide feedback. One of the pilots is the so-called method pilot. We're talking about a leading Spanish furniture manufacturer that is currently expanding, and for this purpose involves logistic aspects in this expansion with the participation of DHL, the German supply company. No, it's not a supply company. Okay, DHL. Because it has recognized the actual limited digitization of supply chain management. So the method pilot addresses optional tracking of suppliers to gain awareness of potential anomalies, and when such anomalies occur, the system tries to find alternative production partners alternative production partners when critical deliveries. System tries to find alternative production partners when critical deliveries are not available. Historical data will also be taken into account to increase the efficiency of such processes. So what we are doing here is that we are driving from static supply chains to smart manufacturing networks. I have a problem.
Don't worry about it. This will be edited. So
no, okay. I just have lost my thought. I wanted to say a few words on manufacturing as a service. So what NARRATE tries to transform traditional supply chains into composable manufacturing as a service ecosystems, very much inspired by the cloud computing model, but here applied to physical manufacturing. It will be a self-orchestrated, service-driven ecosystem. Stakeholders like suppliers, manufacturers, logistics providers, clients who collaborate through manufacturing as a service principles. The digital platform connects clients with all available data, services, and manufacturing capabilities. And the SMN enables on-demand production without owning factories or machines. So this is the model of the cloud computing manufacturing software as a service example. So we use generative AI for AI-driven orchestration in the IMC, the Intelligent Manufacturing Custodian. Collected data will be used to train our learning models according to the data that we are predominantly dealing with. AI algorithms will analyze the data and provide real-time reporting and visualization on the dashboard. You will hear more about that in another episode. So we have to make this possible. We have a programmable digital twin framework. We use Internet of Things capabilities we harmonize and integrate all data from different providers in the network and decorate it, so to speak, with semantics. And we will have sustainability and circularity stress testing tools.
Thank you, Bernd. It's clear that the project is moving at an incredible pace. Frank, what can a NARRATE-powered factory do that most advanced factories today still struggle with?
Yeah, very good question. I mean, on the one hand side, it's also similar to what Bernd has just recently mentioned. But in addition, what we see in today's discussions and in almost every conversation about the future of manufacturing, there's a trend which started only recently. It's about data. It's not the machines, it's not automation, it's not the robotics. It is simply about data. And because in today's industrial landscape, data is, if you wish, the new production line. It determines how fast we can operate, how accurately we can do our forecasting, and also how effectively we can compete. And this comes to different flavors. Let me just address a few. So, for example, what we quite often see is the problem of data fragmentation. Most factories operate with a patchwork of different systems that has been, from historic reasons, been accumulated over decades. So ERP, MES, SCADA, PLC, and all those being combined with a countless number of proprietary machine controllers. And each system works, but none of them works really together. And the result is then a landscape where data exists in many silos, in many different places, everywhere, but it's usable nowhere, really. So this means from a decision maker's perspective, from an executive's perspective, you have slow decision cycles, limited visibility, and also the inability to scale to digital initiatives across different sites. And this is something that we also addressed in NARRATE, namely, there we have aggregated, summarized production data that is being transformed into higher level abstraction, meta level data, and that is also situation and also associated events that are created from knowledge from raw data, and this knowledge framework that will be used also to define these digital twins within the project context, as this will leverage existing standards to standardize data and to metadata level descriptions. And another problem that is quite often seen is the lack of real-time data, and that's something that we especially targeted within the context of NARRATE. Factories today generate enormous volumes of information. Much of this information arrives distributed, it arrives sometimes too late, or it doesn't arrive in a consistent format. So when data isn't real-time, also the following operations, they can also not be real-time. And this means that predictive maintenance becomes sometimes reactive maintenance, as there has been a problem with the machinery beforehand. So there are quality issues that are discovered after a certain fact, and production planning becomes, in this case, rather a negotiation rather than a science. And in the NARRATE, we target this, for example, I think it has been previously also being mentioned by some colleagues. We have this intelligent manufacturing custodian, the IMC, which allows decision makers to collect and analyze data from various different sources. There we have sensors, there we have trackers, and this can then all be combined in one single view to provide a real-time visibility on a particular supply chain. So this enables then firms to quickly identify certain disruptions that they're experiencing, and especially also to respond to respond accordingly, to respond proactively, to minimize those impacts. That's something that Bernd has just mentioned with the smart manufacturing network, because this is essentially just a construct which allows for this quick identification of disruptions and also a quick solution of so your supply chain.
That's a great transition to the technical core. So, Jesús, how can the IMC use neuro-symbolic reasoning to maximize performance and minimize disruptions?
The IMC uses neuro-symbolic reasoning via the NSQA. This is the module that creates the reasoning as such with the help of the LLM. So, let's answer the question with use cases. We'll clarify everything. So, the first use case could be detecting a delay in raw material delivery. So, the platform can have automated tasks checking on a daily basis all the raw material purchase orders. The task could check specifically if we are exceeding the expected time delivery based on the agreed SLAs. If that would be the case, an alert in the form of an event should be triggered and sent to the IMC. This being an automated task, we should have in the platform library a risk and a response plan associated with it. Once the IMC receives the event, the planner calls the NSQA to check for a risk type and a response plan. The NSQA should find both and share it back to the planner, who would create the plan and share it with the orchestrator. The orchestrator would execute all the actions and store the solution in the platform monitoring. At the same time, an SMS alert and an email alert could be sent to the decision makers to act accordingly. So in this case, the solution could be identifying the delayed shipments and switching to an alternative suppliers to prevent a production halt. So therefore, in this case, we are minimizing the disruptions, all right? And when we talk about, all along, when we talk about the platform, we are referring to this NARRATE platform, this ecosystem of AI tools, right? Okay, let's use now a second use case. For example, predicting machine failure and scheduling maintenance. So the objective in this case would be to detect potential machine failures in advance and proactively schedule maintenance. This case would be slightly different from the previous one. This time, the machine sensors would be sending values to the monitoring system, which checks that the values fall in range. If at any point the values start being out of range, the CEP would trigger an alert in the form of an event to the IMC, who would start the same process as previously described. Okay, but this time, the proposed solution to the decision maker would have been to first check machine parameters, to double check that the machine could be close to failure, and then schedule a machine maintenance. So again, we minimize disruptions. Okay. So moving on now to a third and the last use case, which could be resolving production bottlenecks. So we go one step further and even more complex situations to be analyzed and find a proper solution to move on. Okay. In this case, the trigger can come from the user asking a question or through a scheduled task that identifies slowdowns in the production process. In this example, the IMC would detect inefficiencies during manufacturing and dynamically redistribute the workload. So, let's start with the operator manager, worried about the plan he has created for the next couple of weeks. He is not too well convinced of the generated plan. So, after going around a couple of times, he decides to inquire into the IMC to identify any bottlenecks in the production process, anything that could be improved or done differently. The IMC could take the question, talk to the NSQA to identify risk and response plan, if any, and generate a plan. Same as before all the time. If there was no response plan, it would generate one dynamically from scratch. From there, the orchestrator would execute the specified actions in the plan. In this specific case, the orchestrator would probably be calling the tools production planning and process routing system and the reconfiguration of production, and provide with reconfiguration options for this production plan back to the IMC. Therefore, and of course, once it's back to the IMC gets this information, and along with the NSQA, they form the final answer to the user. Therefore, in this case, we are optimizing the performance of the machines by reconfiguring here and there the different activities in the production area. So, from I've done a plan, and I don't know how good it can be. We go into the IMC. We sort of simulate that and receive an answer saying, okay, it is good, but or it could be done in a different way.
Thank you, Jesús. It's fascinating to think of the IMC not just as a black box that predicts the future, but as a system that can explain its logic through symbolic reasoning. This transparency seems vital from human supervisors to trust the system when it makes suggestions. Let's bring everyone together. So, Bernd, looking at the roadmap, what has been the most exciting breakthrough moment so far where you saw the project move on from a great idea to a working reality?
I think the AI capabilities and big data analysis capabilities that we are involving to allow this self-orchestration, that's a real step forward we didn't have before. And I think that strongly depends on the progress of these large language models that we are profiting from here in our project. And
Okay.
I think the second idea is this manufacturing as a service principle that brings completely new possibilities to the population at large. So you can have an idea for a product, and you can make your design and everything, but you don't have to look for a manufacturer or a supply network that is able to produce that product. You can compose your supply your network yourself by finding the proper elements in the production networks, and you don't need to buy machines or anything. You just can manufacture this on demand by building a network on demand and use it, so to speak.
Frank, how would you explain if NARRATE will go beyond the state of art?
So the question is about how NARRATE will go beyond the state of the art. And this is something that the state of the art, we exceed in 4 different dimensions. I mean, one dimension is data visibility and the AI solutions that help to improve resilience and production efficiency. And within the scope of NARRATE, we will design, implement, and validate big data infrastructure in support of supply chain resilience, with a particular focus on data visibility and transparency that will boost the production efficiency by enabling manufacturers to determine how products are produced and how actors operate in the supply chain. Supplementing data visibility and transparency with the aspects of AI and prescriptive AI, this allows us to have capabilities that will improve operation-wide efficiency. It will allow us to identify disruptions and inefficiencies. It will allow us to have a more accurate prediction and reduce failures, and in the end, improve the level of automation. And this, for example, can be achieved by providing accurate end-to-end visibility across the smart manufacturing network, including suppliers, including manufacturers, the warehouses, third-party logistics, using reliable models, simulators, digital twins, decision-making and planning technologies that in the end help to reduce asset downtime, to improve the planning for unknown variations, and to enable a better understanding of the impacts of unforeseen events. And these help us in the end to mitigate disruptions and risk before they become issues, and hence also improve the overall resilience of the problem. Then secondly, NARRATE exceeds the state of the art in the context of smart manufacturing using advanced digital twin technologies. NARRATE will provide a digital twin foundation that acts as a one-stop shop to support a holistic and precise view of production and enhance decision-making. A digital twin will range from a product configurator to a precise representation of the entire smart manufacturing network, with each of its interweaved elements. So we have here the product, the quality, the service, all the different production process representations, and so on. And this is something we dynamically link with the smart manufacturing network. So the digital twin that will provide a reliable model to help reproduce the entire smart manufacturing network's performance, to simulate complex SMNs and processes, and to analyze challenges such as physical flow complexity, disruptions, some supplier concentrations, bottleneck detection, and so on and so forth. So NARRATE will in the end allow us to have NARRATE will in the end give us the ability to create an accurate digital map of a smart manufacturing network using digital twins technology, combined with the ability to advance analytics, to run simulations, and to manage better risk, predict the impact of disruptions in one part of the SMN that might have an impact on the rest of the smart manufacturing ecosystem, and also propose corrective actions. Then there's a third point, the advanced analytics tools for more accurate prediction and mitigation of risk and disruption. Advanced analytic facilities work in synergy with digital twins to form the foundation of the IMC. Their mission is to provide human, for example, the supply chain managers, with more intuitive, easy to operate technologies and more actionable insights to enable them to enact a tailor-made resilience management for unforeseen situations. Advanced analytics will help the supply chain managers to achieve resilience by taking proactive measurements to prevent disruptions and manage risk. And this will also help the smart manufacturing networks to do a self-adaptation to swiftly adopt and accompany logistics and production to varying external conditions. And as an outcome, we have within the NARRATE platform the possibility to analyze every segment of production in detail, to predict disturbances, to respond to external events, to reveal underperforming processes and product components, and to support the partial automation production processes under human supervision. And there's a first and last point that I want to stress with respect to the state of the art that we're exceeding with NARRATE. It is about building and validating smart manufacturing networks and intelligent manufacturing custodians. In NARRATE, we will build an easy-to-access smart manufacturing network that is resilient and capable of self-adaptation in response to external threats. SMNs will be controlled by the IMC which would streamline and automate the production processes and bring smart, data-driven intelligence to swiftly adapt to changing logistics and to production, which have a varying external background or varying external conditions. Improving the resilience of the industrial system and value chains, the sustainability and circularity of the entire production process will be adopted. And as an outcome, the rate will provide a full-fledged smart manufacturing network and intellectual manufacturing custodian, improving production resilience and efficiency in diverse manufacturing sectors, as we have the furniture sector, the electronic sector, or also in the area of 3D printing. This allows us to have a better way to manage and maintain production assets and adjust processes, improve decision-making, and the ability to run simulations and test scenarios in advanced scenarios. This also allows manufacturers to respond more rapidly to situations or changing situations as a crisis, for boosting operational resilience and reliability, thus bolstering sustainability and circularity for the entire production process.
So everyone, if we look 3 years into the future, what is the one expected outcome of NARRATE Project that will make a CEO say, we absolutely have to have this system?
I think we should arrive the state that in 3 years, some of our partners will have implemented this smart network and shown that it really works in practice at a larger scale than you can show in a project like this one. And on the research side, I hope that we can get a little bit forward, maybe in a follow-on project with the idea of the manufacturing as a service, and also going further ahead with the involvement of AI technologies, IoT, as Frank just mentioned, these masses of data that we have to deal with. And that we can analyze and first of all, we have understood how we can harmonize these, how we can provide context to the data and provide semantics to the data. Once this is done, we can increase our capabilities to analyze these data and understand better what they tell us, and then take action. So I hope that both going into practice and also pursuing further research will happen in the future of this project.
Yeah, that is very valid. Let me also add one thing, which is, from my perspective, quite important. In a sense, a system that eliminates blind spots that cost millions today is something that we could, for example, solve using operational predictability. So what does operational predictability means? It means that there are no further surprises. I mean, no surprises in downtime, because we can predict the system's failures already weeks in advance. No surprise in the quality escapes, because the platform all automatically sort of detects if there's a drift in real time and adjusts processes before defects occur. It means no surprise in delivery issues, because the production, the supply chain, the workforce constraints are forecasted and optimized continuously. And it does mean that we don't have any surprises in cost overruns, because energy, scrap, labor, and the throughput, they are more or less predicted based on historic data that have been seen, and hence also controlled proactively. And all of this means that there are more accurate decisions in the end, because leaders get forward-looking insights. There are no surprise decisions, because These insights are well known in advance, and this is not, let's say, a backward looking, but rather, let's say, a prediction to see what will be next. What are the issues? What are the constraints, downtimes, overruns, and things that they have to face with as a decision maker.
That wraps up the third episode. A huge thank you to Bernd, Frank, and Jesús for showing us the innovation under the hood of the NARRATE project. We are moving from the theory to reality, and the outcomes we've seen are a testament of the power of the hybrid AI research. Next time on the NARRATE Talks, we will be hearing from the people on the front lines. Our next episode is titled Partner Perspective, Real-World Application and Case Studies. So, please stay resilient.